Okay, so today in this video we are going to talk about the set model for fractions. Before we get started on the set model, I wanted to review a little bit with some pattern block problems and with some Cuisenaire problems, just because some of the problems are a little bit more difficult, so I wanted to go over a few of the more difficult ones. So this is just an example of like if you're given a specific pattern block and told how big it is, tell what the size of the other ones are. So for this problem, I'm told that a yellow hexagon is 2. Okay, so this equals 2 holes. So it might help if I figured out what my actual hole was in the problem. If this equals 2 holes, then that means that a red trapezoid is 1 hole because 2 pieces make a hole, right? So this is actually my hole here. So that would be the answer right here, is this is 1 hole right here. Okay, so a red trapezoid equals 1. From there, it's not too bad to get the other 2, because a green right triangle, if my red trapezoid, no, I'm sorry, isosceles triangle, if a red trapezoid is my hole, sorry, I'm trying to get all the pieces out, then I know that a green isosceles triangle is going to be 1/3, because 1, 2, 3 make a hole. Okay, so this is 1/3 because 3 make a hole. And then if this is my hole, how much is a blue parallelogram or blue rhombus? Well, it's less than a hole, but it's more than a half because I can't fit another one on there. So it's helpful to compare it to something we can actually compare it to. If I put my green triangles on there, I can now see that 1 blue is the same as 2 green triangles. So 2 pieces is what that makes, and 3 of those pieces make a hole. So 2/3 would be your answer for that. And you should be able to kind of see that. If this is my hole, does that cover 2/3 of the area? Yes, there's like 1, 2, 3 parts. 2 parts are covered. Okay. So if we went to this one's a little bit more difficult because instead of giving you a hole or 2 holes, it gives you a fractional part. So in this example, this is 4/9. So you have to think about it as, if this is 4/9, they gave me 4 pieces or 4 parts, 9 parts make a whole. Okay, so that right there is 4 pieces or 4 parts. What shape can I use to make 4 parts out of that? Well, if you use your purple right triangles, that would be 4/9 right there. Because the shape that I was given, I split it into 4 parts. Okay, 9 of those purple parts purple triangles make a hole. It didn't ask me anywhere what a hole was, but if I needed to tell what a hole was, I could just draw 9 purple triangles. So now the question is, what fraction are the rest of these? So this right here, you could see it as half of that and know the answer from that, or if I know that 9 parts make a hole, I know also that I can fit 2 of these purple right triangles on this. Oh, there we go. So right here I have 2 parts, 9 parts still make a hole, so 2/9 is what the answer is for that. Similarly, how many purple triangles will fit into this? So 2 there, and you can probably just see, as I dig out some more, you can probably see that it's 6 of the triangles fit on that. Okay, so there is 4, and then 5, 6. Okay, so 6 parts, I have 6 parts here, 9 still make a hole, so 6/9. Okay, so this fraction reduces to 2/3, and the reason why is you could also use the brown ones for this, but that's a little bit more confusing. I would just keep it, if you're using purple here, I'd use purple here. And then same thing up here. How many purples can I fit onto this? So let me just move those up so I don't have to pull them all back out. So 6 fit on top, and then 6 will fit again underneath. So 12 purples fit on this. 9 still make a hole. Okay, so you could do this problem a different way. To me, this is the easiest way. Take what you're given 4 parts, figure out what shape makes that 4 parts, and then apply that to the rest of them. Okay, if you look at this one, similar problem. Here, I was given this is 1/3. So this is one piece. What's my hole? Well, 3 of those make a hole. So for this problem, this is my hole, if I wanted to draw it. So 3 red trapezoids make a hole, since one red trapezoid is 1/3. Okay, so that's given 1 part. So it's given 1 part. 3 parts make a hole. Okay, so what size is this? Well, it's twice as big as that. So you could say it's 1/3 plus 1/3 is 2/3, or that's 1 part. This is 2 of the same pieces, right? So I have 2 pieces here. 3 still make a hole. Okay, for this, what size is this compared to, if I was given this was 1 part and 3 make a hole? One way you could do it is say, well, this is half of that, so what's half of a third? Some people have a hard time with that though. So instead, if you just look at your hole, okay, so this is my hole right here, because 3 parts make a hole. What fraction is this? How many of the browns can I fit on there? Well, when you put them all on there, I don't have them all out right now, but when you stick them all on there, you can see 1, 2, 3, 4, 5, 6 make a hole. So one of them is 1/6. Okay. And similarly with the green ones, if this is my hole right here, how many green pieces fit on there? Well, if I filled it all in, I'd get 3, 4, 5, 6, 7, 8, 9 green pieces. So 1/9 is what the green is compared to your hole. Okay, so sometimes you need to have the hole to be able to compare it back to it. For this one, if this is 2/5, what is my hole? Okay, so if you think about what you were given, in this problem I was given 2 parts. So I need to turn this into 2 parts. Well, what shape's going to turn it into 2 parts? The purple right triangles turns it into 2 parts. So now how do I make a hole? Well, 5 parts make a hole. So my answer is 5 green triangles. Nope, that's purple, sorry. 5 purple triangles. And you could try to make a shape out of this. We don't have a pattern block that's 5 purple triangles, so that's just your answer. You just draw 5 purple triangles. You could stick them together if you wanted to, or just write 5 purple triangles as your answer. So I hope this helped out a little bit with the pattern blocks. So let's do a couple of Cuisenaire rod problems. This was our notes from last time that we did. I'm just going to work out some more on the back. Okay, the orange, let's skip 7. Let's go on to 7 and 8. I feel like aren't that difficult because they give you the unit and they're asking what is half, and so you're figuring out what 2 parts make that. So let's move on to 9. So you're told that this is 1/3. So the red is 1/3. So if the red is 1/3, what is the whole unit? Okay, so if this is 1/3, then that tells me I was given 1 part, 3 parts make a whole. So I need to put 3 red ones together, right? Because that is now 1/3 plus 1/3 plus 1/3, which is 3/3, which is a whole. Well, which Cuisenaire rod is that same size? Not black, let's see. Dark green? There you go. The dark green one is the same size. So my answer is dark green. And you need to justify that. Okay, so since you're taking your test in a different location and I can't even look to see that you're using the Cuisinart rods, you'll need to draw these. Okay, so you would draw one red, and you can color it in with a red matte pencil, or you can put an R for red, and then draw your 3 reds, and then show that your dark green is the same length as the reds. Okay. The next one's similar. The brown Cuisinart rod is 2/3. So this represents 2/3. Okay, so 2/3 means I was given 2 parts, 3 parts make a whole. So this right here is 2 pieces. So I need to figure out what color turns that into 2 pieces. Well, let me guess purple. Yeah, so purple shows that's 1/3, that's 2/3. And so total, the total length is 2/3. Okay, so let me draw that real fast. Well, I'll pick it up and I'll draw it underneath in a minute. Okay, so that's 2/3. It asks what is the unit. Well, I was given 2 parts, 3 make a whole. So put a third one on there, that's a whole unit. 1/3 plus 1/3 plus 1/3 is 1 whole. What Cuisinart rod is this length? Well, I don't actually have one long enough, so make one long enough. You could do, like make a train, orange red, or you could do other options. Okay, so I'm gonna say orange red is the answer for this. And then I need to like show my reasoning for this, for like when you turn in your homework or when you turn in your test. Okay, so the reasoning is the brown equals 2/3. Well, that means that's 2 purples, a purple and a purple, and you could shade these in. So that's 1/3 and that's 1/3. Well, draw one more purple. So another third. So when I add those up, I get a total of 3/3. This is my whole. And what shape is the same length? And orange, red. Orange, red. Okay, so just make sure that if you're wanting to use pictures, draw them out and label them well, or you can use words to describe it. Okay, so I hope that helped a little bit with the Cuisinart rods and with the pattern blocks. For the rest of the video, we're going to talk about the discrete model. So the discrete model is also called the set model, and you can use any manipulative for this. We don't have like pattern blocks or Cuisinart rods, it's just anything that you have a lot of. So today I'm going to use these color counters. We've already used them in here, but there's another option for them. You could use Cheerios, you could use M&Ms, you could use, this is specifically about Oreos, that would probably get a little expensive, but you can use whatever. Okay, so for this problem it says here are some Oreos, so let me move my paper and let me go ahead and draw that out. That's 3 by 6, so it's 18. So I said draw that up, lay it out with this, because I want to be able to move these around and kind of show you. Okay, so here are some Oreos. In this, we're going to talk about fractions of a set and how to do fractions of a set. And in this situation, since we're doing Oreos, we're going to talk about putting Oreos in different size packages, because that's kind of what we're doing here. Okay, so the example says, can you see thirds? So can I split the set into thirds? Which means, can I split into 3 parts? Well, yeah, I can put that here and that there. I have 1, 2, 3 sets. This is 1/3, this is 2/3, this is 3/3. Or like, this is 1/3, this is 1/3, this is 1/3. When I add them up, 1/3 plus 1/3 plus 1/3 equals 3/3, a whole set. Okay? So how many cookies will you eat if you eat 2/3 of the cookies? Well, if I eat 2/3, that's eating 2 of my 3 sets. So how many cookies is that? That's 6 plus 6 is 12 cookies. So 12 cookies. And the whole 6-pack idea is that's how big my set is. Like if I put this in a package, that's a 6-pack of cookies. This is a 6-pack of cookies, that's a 6-pack of cookies. Okay? So look at number 1. Can you see ninths? How many Oreos will you eat if you eat 4 ninths? So, put my set back together. Can I split this into ninths? Well, if you look at it, if you think about it, like I have 18 cookies. If I split it into 9 groups, that would be 2 in each group. Okay, so there's my ninths. 1/9, 1/9, 1/9, so on and so forth. When I add them all up, I get 9/9, which is a whole set. Okay, so 9ths would be, you can draw it, you can draw this picture if you wanted to, or you could describe that as each 9th is a 2-pack of cookies. Okay, so a 2-pack of cookies is 9ths. So how many Oreos will you eat if you eat 4 9ths? If I eat 4 of my 9th sets, well, that would be 2, 4, 6, 8 cookies. Okay, so 8 cookies. So I took my whole set, split it into 9ths. I took 4 of those 9ths, and that ended up being 8 cookies. Similarly, can you see 6th? So if I did 6th, that would be like, I could split it like this. I don't know if you can see that very well. So like, here's 1 set, here's 2 sets, here's 3, here's 4, here's 5, here's 6. So 1/6, 1/6, 1/6, so on and so forth. If I wanted to eat 5 6, that would be 5 groups out of 6, right? So that would be eating all these cookies, and that would be 3 times 5 is 15 cookies. Okay, so 6 would be, there's 3 cookies in each set, so it'd be a 3-pack of cookies. And then the amount that I would eat, 5 3-packs would be 15 cookies. Okay, so I'm going to skip these last two because it's the same idea. 36, that would be half a cookie in each set. It's kind of a little bit harder to do with my manipulative, but I could draw it. I could split each cookie in half. So let's move on to the next example. Here are some chocolate and vanilla cream cookies. If we put these cookies in 6-packs, how would you name the part of cookies that are chocolate? Okay, so let's see. So kind of turn these around like this. Let me add some more on there so I can get this example. Oops. Okay, so those are all the, well, crud, those are supposed to be the chocolate ones, I guess, and these would be the vanilla ones. The red ones are going to be the vanilla. I don't feel like flipping all those over. So let's see. So I set it up to where yellow is chocolate and red is vanilla. Okay, so it says, if we put these cookies in 6-packs, how would you name each part? How would you name the part of the cookies that are chocolate? So 6-packs would be, there's 1 pack right there, there's 1 pack right there, there's 1 pack right there, and then there's a 6-pack right there, 6 and 6. So I have 1, 2, 3, 4, 5, 6 right here. Okay, so what part of the cookies are chocolate will have 2 of the packs out of a total of 1, 2, 3, 4, 5, 6 packs? Oh, I'm sorry, I'm doing it backwards. These are vanilla, that's chocolate. That's my bad. So again, starting over, this is my chocolate over here. So the part of the cookies that are chocolate is 1, 2, 3, 4 sets out of a total of 1, 2, 3, 4, 5, 6. So that's how they got 4 out of 6. Okay, so let's do the same thing, but with a different example. So same set. If we put them in 4-packs, what part is chocolate? So let's split them in 4-packs. So 4 cookies in each pack. 4, 4, 4, 4, 4, 4. So what part of the cookies are chocolate? Chocolate's yellow again. So 1, 2, 3, 4, 5, 6 packs. So pick 6 packs are chocolate. Out a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 packs. So 6/9 of the cookies are chocolate. Okay. If we pack the cookies separately, which part is chocolate? So separately, that means each cookie is its own package. Kind of line these up a little bit better. So the number of chocolate cookies I have is all the yellow ones, which I have 24 yellow ones out of a total of, so 24 out of a total of, there are 24 plus 12, so 36 total cookies. 24 out of 36. Okay, I could keep on going. I hope that you're kind of recognizing, isn't 4/6 the same as 6/9 and the same as 24 over 36? These are all equivalent fractions because it should make sense. I'm asking the same question every time. What part is chocolate out of total? What part of the cookies is chocolate? So it's the same answer. It's just different ways of looking at it, of equivalent fractions. Okay. So the set model is taking a set of something, splitting it into parts, like however you want the specific problem calls for, and then going from there to answer whatever question you need to. So if you'll look at the back of that, this is kind of what the discrete model looks like on paper when you're not using an example of cookies or whatever. So if you look at the first one, it says the given diagram has a value of 2/3. So those 6 dots equal 2/3. And they want us to show 1. Okay, so if that equals 2/3, that tells me I have 2 parts. I was given 2 parts, and 3 parts make a whole. So I need to split this set into 2 parts. So for this one's pretty easy. 2 parts right there. 1 set of 3 dots, another set of 3 dots. That's my 2 parts. To draw the whole, I need to draw 3 sets now, right? Because 3 sets make a whole. 1, 2, 3. And there are 3 dots in each set. And that's a whole. And if you wanted to go ahead and label your fractions, if this is 2/3, that means that this first set is 1/3. The second part of the set is another third. So this is 1/3 plus 1/3 plus 1/3 equals 3/3, which is 1 whole. Okay. For part B, the given diagram has a value of 1. So this equals 1 whole. I want to show 3/4. Okay, so if I want to show 3/4, I'm going to do 3 parts, 4 make a whole. If I'm given a whole, I need to show this as 4 out of 4 parts. So with the number of dots I have 1, 2, 3, 4, 5, 6, 7, 8 dots. How can I put that into 4 groups? Well, 1, 2, 3, 4. So that's 4/4. Now to show 3/4, I just need to show 3 of those sets. And there are 2 dots in each set. So that's my answer, and this is my answer for this one. For part C, the given diagram has a value of 2 2/3. Show 1. So 2 2/3, to figure out the number of parts given, I'm going to go ahead and make that an improper fraction. 2 times 3 is 6. 6 plus 2 is 8. So this is actually 8/3. So I was given 8 parts, and 3 parts make a whole. So if I was given 8 parts and 3 parts make a whole, I'm going to split this into 8 different parts. So that would be 2 in each set. Kind of overlap that one, sorry. 2 in each set. To show 1, 1 is equal to 3/3 in this situation. So I need to show 1 is 3/3. Which is 3 sets that have 2 dots each. 1, 2, 3, 4, 5, 6. And that's my answer. Okay, for part D, it says if the given diagram has a value of 1/3, show 1/2. So this right here is 1/3. I was given 1 part, 3 parts make a whole. So if I was given 1 part, I was given 1 set right there. It asked for 1/2. Before I do 1/2, let me just go ahead and show a whole. Okay, so 1 whole is equal to 3 out of 3. 3 parts out of 3 parts make a whole. So that would be 3 of these sets. 1, 2, 3 of those sets, which would be 12 dots. Now can I show a half out of that? Sure. So let me rewrite my 12 dots. 1, 2, 3, 4, 5, 6, 10, 11, 12. Can I split that in half? Yeah, no problem. So that's 1/2 and that's 1/2. So 6 dots is my answer there. And then for number 2 on the bottom, what fraction of the circles in the diagram below are black? Your answer needs to have a denominator other than 12 and justify your answer. So let me go ahead and do it with 12. What part of my circles are black? Well, I have 1, 2, 3, 4, 5, 6, 7, 8 black circles out of a total of 12 circles. So 8/12 is one way to write that fraction, but it said pick something other than 12. So let's do, like our Oreos, let's do these as 2 packs. So put them in groups of 2. If you put them in groups of 2, I have 1, 2, 3, 4 sets or 4 packs that are black out of a total of 6 sets. So 4, 6 would be an answer, which 8/12 reduces to 4, 6. You could also do groups of 4 if you wanted to. You could do, that would be the most you do is groups of 4. Okay. So your homework is attached to the week, and it has a little bit of all of this different models, mostly the discrete model, but it has a few of all of them.